All right, guys. Welcome to AP Calc. So I think everyone's here. I guess before we start, I'm just gonna have you guys look at my Remind page, like remind.com. Did I send any messages this weekend? Okay, I did. Okay, and did anybody not get the message? No. Okay, so just make sure. Hey Joseph, can you hit the lights? Maybe like one or two of the lights. All right, can everybody see the screen? Okay. Just check to see if your name's on here really quick. Does anybody not see their name on here? So I got Ashlyn, Alana, Emily, Gabby, Gray. Does anybody not see their name on here? Okay, I think you guys are like the only class that everyone got on like the first time, so be happy for yourselves, okay? Okay, here's your first task. This is a warm-up, okay? Uh, Also, please make sure at some point you grab the handout that I had on the front table over here. So it's stapled. Let me put it under the microscope here. It's stapled in a weird way, so you can actually put in your binder sideways, or you can put in your binder this way, however you like, or you don't even have to put in your binder. But let's go ahead and get on to our warm-up really quick. I want you guys to find, maybe not this one here. This is a parent function, but I want you to find the equation for this line based on what you see, okay? I can manipulate this however you like, this graph however you like. Like I can put some points here and points here. We're going to do a little bit of an experiment here on whether you can determine the function just by looking at it, okay? So why don't you work with a partner or whoever you like, and then once you have something, write it down on the board so I can see what functions you guys end up coming up with, okay? Okay, that's your task. Write down the function for this blue line. What is it? This red line should help you with what it is. I'm gonna give you guys like 5 minutes to do this. Does anybody recognize what kind of function the red one is? And it's an exponential function. So the red function. Would it help if I gave you the red line first? Or okay. Okay. So the red function is base 2 to the x power, okay? With that, can you find me the function that is the blue line? Let's see here. Yeah. I can zoom out a little bit if you guys want to see. Does that help zooming out a little bit or no? Yeah, it's kind of hard to see, huh? Okay. Can kind of move it around a little bit. All right, anybody got anything so far for this function? What it could be? The blue one? What's changed from the red function to the blue function? Yes, Ashlyn. Yeah, it's for one, it's moved over to the left, so maybe I can have like 2 windows up right now. Okay, it's giving me some difficulty doing that. Okay, so the blue function seems to be moved over to the left. Is there anything else that has occurred with the blue function in comparison to the red function? My clue is, yeah, Joseph? Okay, and can you identify how many units it's moved down? I think to the left is kind of tricky to figure out how many units. 3. So we know that for shifting and transformations to a parent function, so I don't know if you can kind of see that right there, but I wrote 2x to the x power. How do we represent a shift that goes up and down, like a vertical shift that moves this red function up or down? How do we do that in graphing an exponential function? Does anybody remember? Okay, let's see. It should be represented by a number. On the outside, you can add or subtract the amount of units you move up and down. Okay, so in this case, what do we want? Do we want to add units or do we want to subtract units? Yes, so subtraction is correct. How many units? 3. There you are. So now that represents a vertical shift. The horizontal is kind of hard, so I'm not going to lie. I don't think anyone's going to be that brutal to you unless it's like a parabola. I think a parabola would be a little easier to identify. But if we move it to the left, as Ashton kind of put, where do we represent the shifting, the horizontal shift, as we call it? Yeah, we put that in the exponent. If we move it to the left, though, is an addition or a subtraction? Yeah, it's kind of opposite from your thinking, right? So I'll give it to you. It's 3 units as well. Okay? So if you want to make a note to yourself, you can draw this kind of graph to our left, kind of quickly on your paper, just like a quick little sketch here. An exponential function usually crosses the x-axis at 1. And I guess this guy kind of shifted down 3 units. So that no longer cross at 1, but it should cross at -2 maybe. So down to 0, 1, 2. And it should shift over, I think 3 points. 1, 2, 3. So like, let's just say at this point, this was at, 0, comma 1. This should be theoretically at -3. Whoops. -3, comma. I'm sorry, that's really hard to read. Let me fix it quick. This is at -3, comma, -2. Okay? And if you need to remind yourself, this represents a vertical shift, this constant, and then this represents a horizontal shift, as Risa pointed out. Was this a super hard question? It was pretty difficult though, yeah. So my recommendation is to really go back on the parent functions and really learn them, and then just learn some key features. Like if typically if you put numbers next to your x value or your x variable, that always represents a horizontal shift, no matter what function you're kind of looking at. And if you have a constant on the outside that you're adding or subtracting, usually that means it's going to shift whatever graph you're looking at up or down as well. Okay? So those are some key things to kind of take away from this. All right. Let me see. Did I want to go through anything else? Okay, and today we're going to be going over, I think, 1.3 and 1.5. Did anybody have a chance to watch the videos that I posted up pretty late into the week? I would say like on Monday or I think Sunday. I was able to post them up. No? Okay. Just a brief overview. Mr. Wee's class. Because in theory, if I was to continue directly off of where I left off last week, we would be a few sections behind. So in order to compensate for how much material that I want to go through that I can't go through in class, I make new videos as well. So I make other videos to kind of supplement the lecture videos. Hopefully this is just kind of redundant news to you guys, but the only difference is I want you guys to see the value in what I'm saying. So last week, the lecture from last week is posted up already right here. Okay, it's mouse is hovering over it, and then oh, so unfortunately, last week, I know it's not good news, but there was no sound that was recorded. But this week, you can kind of see I have my headphones on, my fancy headphones. Okay, so there is sound being recorded. I've test drove it a few times. It works really well. But if you just want to see how I took the notes, whatnot, then you have the lecture. Below this, though, are two new parts. Sean actually pointed this out as well. There were no links to this before, but now I made two new videos. These are the sections I didn't cover in class. So we're not doing 1.2 today, but it's been covered already in these videos. So what does that mean, though? What does that mean that you guys should do? Probably watch the videos, okay? I know it's more stuff that you're like, I don't want to watch it. But if you're really being confused or you're really confused on what I'm looking for, like from what I want you guys to know from 1.2, hit up these sections, okay? Like it should tell you the notes from the notes, what I think is really important from the notes or from the sections. This stuff here, only half of these videos work. If you wonder why, I'm going to update this depending on how far I get today. These are from last year. These are the things that I couldn't cover in class. That's how much stuff that I usually cover. So hopefully this can get cleaned up. I think only the last two videos work for now. Okay. The reason why is all these videos were on my drive, and then part 6 and 7 were on YouTube. That was when I kind of like smartened up and was like, oh, I should probably put this stuff on YouTube because that's a lot more accessible to most people. And I inadvertently deleted by accident these videos from my drive. So these don't exist anymore. Parts 1 through 5 don't exist anymore. This should look cleaned up by the end of the week. So by today, you should see the lecture video today from right now. And then the rest of the videos, the other stuff that I couldn't cover, should be up by, I would say, yeah, by the end of the week, hopefully. Okay. Any questions so far? And then handouts are usually on the bottom. Okay. So let's get to it. We're going to continue down with some more notes, and then I'm going to have you guys do some problems too, so you guys just don't sit there bored out of your mind, okay? Listening to Mr. Wee talk. Okay, so before we get into, or actually, yeah, let's go ahead and start with 1.3, exponential functions. Let me know if I'm going too fast, okay? Thank you. They are quite stylish, I would say. Okay, so just a brief review, okay? Exponential functions are usually a base to some exponent x. And if your b is greater than 0, your base is greater than 0, but it is also not equal to 1, then your, your domain should then be all real numbers, if that's the case, okay? What that would look like, the graphs, what your graphs would end up looking like. So some general forms here. Again, if your graph was y is equal to b to the x, and your b was greater than 1. Oh, can you guys give me 1 second? That's my phone. How embarrassing. Go ahead and catch up on writing some of the notes while I turn off my phone. That's so rude, guys. I'm so sorry. Obviously, I can't have double standards, but if that happens to you guys, just silent your phone. So I won't be mad because I'm prone to doing it myself. Okay. Okay. So, just a brief overview. If you have a situation where your base is greater than 1, then you should get graphs that look like this. They always cross at what point on the y-axis? That that is correct, but I'm just asking right now, what does it cross? Yeah, it always crosses at 1. And if you change your base, it might come in steeper. If you're not changing it by much, it just comes at different steepnesses, but it's the same general form, okay? And then if you have a situation, again, where you have your b value that is less than 1, but still greater than 0, then, as Matthew said, what did you say we would end up seeing, Matthew? Yeah, they're sort of kind of going in an opposite direction. I have a really hard time with drawing this too. I don't know why I'm so bad at drawing it the other way. Again, at different steepnesses depending on what your base ended up being. And I'm sorry if I can't quite capture this, but it always hits what's called a, what is that called when you like slide against like a certain number on the x coordinate, but like it never actually crosses it. Yeah, it has an asymptote consistently. As long as you don't end up shifting it wherever, it usually has some horizontal asymptote. Okay, those are some general features there. Does anybody know if I made it my b value that's greater than 1, but it's negative? Does anybody know what would happen here? Can anybody guess? Any guesses here? If instead of having my b value be 1, but it'd be like -1, like it had to be -1, -2, -3. It's impossible. Let's see what would happen. Yeah. Yeah, I might be exploring something that I shouldn't be exploring. Oh yeah, huh? It does not. Oh, I see. I see what I did here. Order of operations made this whole thing up. Okay, okay. Scratch that. Okay. So, sorry. Scratch that last thing I said. Okay. So we'll just focus on these two scenarios here. Okay. Okay. So brief reminder, and then we're actually going to go through actual sample problem now. Okay. So here's a sample problem that you're going to encounter. So this is typically the format of my class. I'll go through some brief things, just some fundamental knowledge, and then some sample problems for the section that I think is really important. Okay, so here's a sample problem. I think it's 39. It's technically number 39 on 1.3, but this is definitely a type of problem that I think you're going to see a lot. So you're given that the graph of an exponential function, let me see if I can hide all that stuff and hide this prompt here. Y is equal to a times b to the x, okay, is shown below. So you may see your exponential function sometimes written with an a, like a coefficient in the front being multiplied to the base. That happens. Is shown below. Now you got to find a and b. Here's the graph below that I'm talking about. It's an exponential function. So the first point, I'm going to roughly draw like a increment of 1 here. That's 1. And then 6 increments up on the y-axis. 1, 2, 3, 4, 5, 6. Actually, let's go up 9. 7, 8, 9. Oh, dear. Mr. Wee. I'm so sorry, guys. That's not the most pretty graph. But 1, 2, 3, 4, 5, 6. What's up? Oh, why am I referring myself in the third person? I don't know. I'm sorry. That is a mystery that I can't answer, or Mr. We can't answer. Okay, and let's just say that exponential curve, and if you can't see those 2 points, that's 2, 9, and that's 1, 6, okay? Given just this information and this equation, y is equal to a times b to the x power, we have to solve for a and b. This looks like it's going to be a really difficult task. Yeah, Stephanie, do you have Okay, did everybody hear what Stephanie suggested? Okay, so let's try that. Why not? Okay, so not a bad suggestion. Not a bad suggestion. So let's start with I'm going to call this step 1, okay? And I'm going to say, you want to replace 1 and 6 first? Okay, why not? Okay, so 1 and 6, meaning that's the points x and y. So I'll replace 6 in place of the y, and a times b is equal to, or to the power of 1, okay? So now I have this weird statement, 6 is equal to AB. Any other suggestions for what I can do now? So I got 6 is equal to AB. How is that going to help? How is it going to help? Let me see. Yeah. Let me take a look at my notes here. Okay. 6 is equal to AB. Whoops. Okay. Okay, my next suggestion is to use the other point to your advantage at step 2. So I think, Stephanie, you were trying to, I think you had that in your mind, but you're trying to figure it out in your head before saying it out loud, right? Okay, so that's pretty good. So we're going to use 2 and 9 as your next point here. So we're going to replace the y with 9 and then AB. And now in place of the exponent, where the x is, we're going to put 2. How can I link my first step and my second step together now? Okay, so let's have a look here. So let me rewrite this one more time. It's now I have a situation where I have A times B, and technically there's 2 B's. And if we're creative here, this we kind of have, and we already have what AB is equal to from the first step. We arbitrarily made AB equal to what? 6. So why don't I just put that in? Where 6 is AB times B. And then at this point, I can solve for what letter? B. So if I divide both sides by 6, I get, I think, 3 over 2. It simplifies down to is equal to B. And then my last step is to solve for A, because I know that 6 is equal to AB. 6 is equal to AB, but I figured out that B is the 3 over 2, right? So that should be 6 is equal to A times 3 over 2. And then if I want to leave by B or A by itself, I just multiply maybe 3 over 2 by its reciprocal to kind of cancel it out, 2 over 3. And then whatever I do to one side of the equality sign, I must do to the other side. So now I end up having 12 over 3 is equal to A. Sorry, I know this is very messy, so let me box my steps so you guys can kind of follow along. This is step 1, this is step 2, and finally 12 divided by 3 is 4, which is A. Sorry, very messy, but I don't know if everybody can see that. Let me zoom in manually here. Any questions so far on this one? I'm going to give you guys one of these problems, and then you guys are going to work on it. Are you guys up to the challenge? Okay, this one isn't exact. It's set up like A, B, and you got to use some substitution, but it's not exactly solved like what I just did just now, okay? So I just don't have time to go through a lot of these types of problems. So I'm gonna launch you into one where I don't know if you're gonna figure it out, but we're gonna give it a shot, okay? So here's the one that you're gonna try. It's actually number 40 in your book. So if you like, you can actually go to slater.com and check out the solution for yourself too, as well, if you want to work backwards. However it helps you, okay? And here's the graph. It's set up almost exactly the same way. Here, I know it's not very pleasant to look at, but this is -1, 8, and down here are the 2 points given, 2, 0.125. Uh-oh, that's not a pretty whole number. I'm so sorry about that. Again, solve for A and B. You're left with this equation, okay? All right, guys, please stand up now, okay? Get out of your seats now, okay? Stretch a little bit, because I've been just talking for a stretch of time now. Find a whiteboard space, any whiteboard space you can, including the ones that are on the outskirts of this class, within the class, and then find some markers, some erasers, and go ahead and go to town on this guy, okay? Solve for A and B. I'm going to give you guys 5 or 10 minutes to try to solve this problem. Get creative. This is not easy. This is a tough one, I think. What's up? Why is it different or what?
No, the window.
What?
It's broken.
Whoa.
Someone threw a rock.
Whoa.
I asked the janitor and it was there for a while.
Oh, really?
Yeah.
Was it during the summer or just now?
It was the last it was before the school started.
Who would do that? Yeah,
I think I know who it is. But
I thought you said, I think I did.
I think I know who did it, but
Alright.
I'm just gonna stay silent on that.
Okay, alright. Well, I would like that you would help, but it's okay.
You will probably know too.
Yeah, but I can't.
This one's broken. I mean, it doesn't have anything.
You know what you do with these?
Throw them away.
No, you eat them. Yeah, you definitely throw them away. Okay, guys, get to work on this one. See if you guys can solve for this. This one's hard. This one's hot. Stevie, can you turn on the light, please? So everyone has light.
Yeah, I didn't even see that until yesterday when I was walking into Mr. C's office.
I've never noticed that. I haven't even seen the front office in like forever, so.
It's like there's like walkthroughs and like
Dave Porter or it's just Apollo. I mean, he's just doing his job, so he's just like, I don't know what I'm doing wrong. I'm just doing what I'm trying my best. He actually works really hard. Mr. Zabala, out of all of us, he stays in the office like most of the day, just like working away. So as a teacher, I'm just like, hey, Ron, do you think you can do this? And he's like, I'll try my best. I really have to. He's got a pretty insane job.
Yeah, they're trying to get the window repaired, but the guy's busy.
Really?
Yeah.
That's like the whole district right now.
In my old school, that never happened.
Really?
Never.
I wonder why we get so much hate. Why we get so much hate. Anybody figured out B?
I found it. I figured out A,
Okay, so that's what you guys.
which is equal to 8
What's another?
and then I'm gonna solve
express
B.
A and B to the negative. Punched. Okay, go ahead. What? And then it's not exactly like the last one, but you can figure out what A is. Step. By getting rid of the B.
Well, I mean, you can just write A is
Or A is A is a 8B. Yeah. Who smudged that one? Huh? 8B. Okay. Now, I would say stay with what you got. You got some information that you can use. Use the other. How are you guys doing here? This is a very tough one. Oh, that's -1, 4. It's just Mr. Wee has the.
Oh yeah, that's very good. Yeah, I'm getting away from you.
Give me another marker.
Alright, let's have
Risa, I think that's the same one that you guys were.
Well, it's not very
It's like I was doing a problem with the textbook, and they were like, "Oh, you're getting this positive attitude, so you have to take it away." And I was like, "What?"
Okay, so you're at this point here. Another way to express need is negative first power.
Sean, what? You're getting these 1, 2, 5,
So once you start with
What?
It's very.
and then you can solve for a.
Alright, but why?
Yeah, there you go.
Is it
Now we stop there, and then now you go to the.
And another problem is.
So you have that. Now you have this. 0,
I am.
5 C third. I found out that even if you find that number, it's gonna be the calculator or something.
Oh my friend, this is tough. Where are you at? That's so good. That's great. Now you have 8BQ. Can you solve for B? Yeah. You guys are doing very well. This is actually surprising. I didn't think anybody would get this.
No. A negative exponent means eh.
Yeah.
This is attempt number 2.
Yeah, the first time we got some really bad ones were actually like, let's just try it. Okay.
Yeah, I realized.
Is it right now?
Alright, I guess I'll give you guys like another minute.
So I don't know how to use the calculator.
Some of you guys are really catching fire here. You guys are on fire. I like it. You guys are on fire. Wait a minute, Stephanie. I'm just playing. I'm just kidding. You're good. Don't doubt yourself. Huh?
Like root tree here.
Oh, root 3? Oh, come here, good sire. Wait, do you know?
The math button.
Yeah, there's no actual quick way to do it, so you have to just go through math and find it. So there's an option that I think it's the 4th option, where you can go here, where you can actually put in whatever.
I don't think it sticks. Is it?
It is. Try putting 2 in there and then putting like 4 like into the actual.
Well, how do you delete clear?
It's alright. It happens. So go back to. Let's try it out at the 5th one. So go ahead and press enter. Or 5 or enter, however you like it. And then go back here. Oh no.
Oh, you're right.
Yeah, it doesn't actually
I think we're good.
It's pretty tough. Alright, guys, go ahead and have a seat. I'm impressed. A lot of you guys actually figured this out. I didn't think anybody would figure it out. Whew. You guys are full of surprises. Yeah, you guys are really good. I'm like really surprised. All right, guys. All right, have a seat. I'm not going to tell you the answers right away, but I'm going to go through the quick method about how to do this. I I am so happy that you guys really got into this, and some of you guys even got the answer. I was just really happy that you guys are into this at all. Like, instead of just being like, I don't want to do this. This stinks. So I'm actually really happy that you guys were like, let me just give it a try. And some of you guys even got the answer. So I'm pretty surprised. Pretty surprised. Okay, so any suggestions for what to do in the first step, guys? Help me out. Help me out, as if Mr. Weed does not know how to do it. A lot of times he doesn't. So.
The other one, and then put in the x and y values for the x and y values in the equation.
Which point do you want to use first? Anybody have any suggestions? Yeah, well, I like going the easier route. I don't know. That's just how I am as a student. Yeah, I'm just like, I don't want to deal with that. I want to deal with this. Okay, so let's go ahead and start with that. We have 8 is equal to AB to the negative first power. And then here's where I would get stuck. I would just sit there and be like, I don't know what to do, and I don't want to do this anymore, okay? But a lot of you guys trudged on and found the way, okay? I don't know how you guys did, but this was me. All right, so if you have a negative exponent to the first power, what does that mean that we can do with this b base? Yeah, we can write it as this actually goes into a fraction into the denominator at this point. If it was b to the negative second power, it would be b squared on the bottom. Does that make sense? Okay. And then with that, I mean, I don't like the way this looks, but I like to just narrow it down to one letter. So I'll just multiply both sides by b. So I have 8b is equal to a. So I have something that is equal to a. It's not pretty, but hey, I kind of get the rhythm of these questions. It's like as if the first one kind of sets up to solve for the second one, right? The second step. So I'll leave that. I got something for a is equal to something. I don't know. It's not pretty, but it's there. Okay. And my second step is let's start over again with y is equal to ab to the x power. And then this time let's use the other point, which is 0.125 is equal to a times b to the second power. And then this time let's write it out. What that actually looks like, a times b is what I mean. Okay, what does b squared actually look like? It's b. It's 2. Oh, Joseph, can you hit the light? I think a lot of people are having to squint to see, so I don't want that to happen. Okay, thank you so much, Joseph. And a lot of people, like myself included, like, what can we do with this? How can we connect the first step to the second step? So I think a lot of people overlook this, but technically we do have something for a, and then we can actually plug in 8b for a. That's a tricky. And even then, it would be like, what the heck do I have here? I don't know what this is. Okay, I don't blame you, but what you can do is you can do 0.25 is equal to 8, and now you can condense the b's into b cubed. And then hopefully you might suddenly realize I might be able to solve for b, like a numerical value at this point. So if you divide both sides by 8, what's 0.125 simply divided by 8? What does that simply what is it equal to? No, what does that simply come out to? 1 over 64. Oh, that's a nice way of putting it. Okay, 1 over 64 is equal to b cubed. That's what I have at the moment. And then I could cube root this to get rid of the cubic power here of b, so I can just get b by itself. And you should get, I think, a quarter. Not a quarter, like a literal quarter, but like 1 over 4 or 0.25. I'm going to show you how you do that on your calculator in just a second, by the way. And then step 3 is to go back to 8b equals a. And then you plug in 1 over 4 over a, or is equal to a. Or 1 over 4 times a is equal to a. And then that should give me 2.
Is this your personal calculator?
Oh, it is? How'd you know that? Oh, that's fine. Oh, I see. Okay. Does it have a... Okay. And in case you don't know how to do this on your calculator, does anybody have their calculator with them? You can follow along with me or just kind of mentally soak it in, all right? If you don't know how to do a cube root, normally I would say, hey guys, best way to look at it is to look at each of your keystrokes or your keys and see, I see a square root, okay, but I don't see a cube root. Let's look for the cube root. And then you're like, you put up your hand, you say, I don't know. So if you don't have it, you go to math. You go to math for operations. And then this is at the math button is basically a catalog of all the operations you can do with your with your calculator. And you have two choices. You can either do 4, which is just a cube root right away, and then you just put in whatever number you're trying to solve for. I want to give you a more robust way to solve for things. Number 5. I don't know how fancy your calculators are, but my TA84 can't actually get into that x, that x exponent. If I try putting a number right now, it like completely overwrites everything I just did. So if I go back to math and I go down to the 5th operation, I can either press the number 5 or I could press enter, and I could scroll down and actually highlight number 5 and press enter. Where it says answer, you actually put in your number that you want to put in the exponent. So if you don't believe me, you can test out something like 2. 2 is the exponent in there now, and then I put that's basically the square root of 4. That should come out to 2, and it indeed does work. Okay, that's a check to see if what I did was correct, my thinking. But in this case, it's 3. That should go in that little X right there. Okay, and then my number was, what is it, 0.25 or something, or what was it, or 1 over 64. I'll like put in parentheses 1 divided by 64, and I should get 0.25. Okay, does that make sense? Any questions on how I just did that? Magic. Okay, this is pure majesty and magic. Okay. All right, we're going to move on to 1.5, inverse functions. I do want to go through 1.6. I have a very good feeling that's going to be a video, okay? But 1.5, my hope is that we can get through 1.5 today, okay? So bear with me. There's going to be probably about 15 minutes of pure notes and then another practice problem, okay? The fun begins. Okay, so that handout I gave you has to do with this section. It's just a brief reminder. I literally just grabbed these from the book and made a handout out of it. But this is a brief reminder of properties of logarithms that you might want to just have in the back pocket of your brain, okay, when you're doing this section. Okay, inverse functions. If I have f of x, what does an inverse function look like in comparison to f of x? Does anybody know how I should write that out if I want to make an inverse function to f of x? Just the notation. Yeah, there you go. All right, that's the inverse function. So you don't have to write that down, but if you did, this is the function. This would be an inverse function. Just a quick reminder of what we're looking at today. Okay, so before we do anything, let's build some context. I'm going to go through with what's called a one-to-one function. Does anybody recall what that means if I say one-to-one function? Oh, say that one more time, just really simply. X values, each x value has what? Okay. If you're not following along with what Stephanie just brought up, okay, let's build a quick diagram. It's a little bit of abstract thinking, but it's with familiar concepts that you already know. This is, let's just say I have a domain of multiple x values. X to the first power, or not x to the first power, but x1, x2, this is like a second x value. Let's say dot, 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 all the way to xk. I know that's weird, but that k just means I don't know where this stops. It could be a bunch of x values, but let's just say that's like the very last x value of this domain, okay? Conversely, I have a range that is y1, y2, dot, 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 yk. And then this is your inputs, and this is your outputs. Basically, you run these guys through a function, and then you should get a single output for each input. Each x value has one accompanying y value output. Can anybody guess what a non-one-to-one function might look like before I even finish drawing it? Any thoughts on what this might look like if it's non-one-to-one? This is one-to-one because every x value has a y value. What does a non-one-to-one function look like? And I'm sorry if I'm making anyone feel uncomfortable, like, should I know this stuff? It's like, no, I'm just putting it out there, like, in case anybody does. But hopefully your minds are critically thinking, like, what could he possibly be talking about? I don't quite understand. Well, a non-one-to-one function, this is the domain, and this is the range. A non-one-to-one function might look like this. You have multiple x values that somehow go to maybe one similar y value. That's not one-to-one. I'll give you an example of what that looks like visually. This, my dear friends, is a one-to-one function. Every single x value has a unique and special y value that no other x values share. Can you guess what a non-one-to-one function might look like? A parabola. What else is a non-one-to-one function? A what? Okay, definitely a circle. As you can see, there are multiple, or is it, in this case, I think an x value has two y values. That's not good. That's definitely not good. And I'll give you one more. It's very similar to the parabola. Nothing special here, guys. Oh, and ellipses works too. I was just going to say absolute value function does not work as well. Let's just make it even easier here. Do you remember the test that you have to kind of put through your functions to make sure if it's a one-to-one function or not? You've been doing it this whole time. Yeah, the horizontal line test. If you pass the horizontal line test, meaning you draw a straight horizontal line and it only touches one point, you are a one-to-one function. If I do this at every point on this graph, I cannot say that. You can clearly see I'm hitting 2 points. That means that I don't have a one-to-one function, okay? Not every x value has a unique y value. This circle did not pass, and this absolute value graph did not pass. So these are not one-to-one functions. So to make it easy, just graph it, see if it passes. It's not one-to-one. Why is this important? Why am I bringing up one-to-one functions and whatnot? Everybody got this so far? The reason why is if we want to talk about inverse functions, we got to know if your function is one-to-one. The whole premise behind inverse functions, or some of the rules I'm about to describe to you, it's predicated on the fact if your function is one-to-one. So if your function is one-to-one, one-to-one, quote, I'm going to put that in quotes, you can reverse, you can reverse, okay, like a weird verb, reverse the outputs back into your inputs. I'm sorry, this is completely written in layman's terms, meaning I'm not trying to be rigorous with the way I write this, okay, with nice mathematical language here. Because hopefully you can look at your notes and be like, this makes a little bit more sense to me than if I wrote this in crazy mathematical language here. So imagine this is your inputs. You put it through a function. You put it through some function, and you get spit out some kind of output. Well, if your function is one-to-one, you can actually reverse the order going backwards. You can go from your outputs back into your inputs if you put it through the inverse function.
And if it's not one-to-one, then you don't have a function.
Yeah, exactly. You don't technically have a function if you're not one-to-one. Technicality. And I know this is weird, but actually I'm gonna save that note, the last thing here. So here's a property. Here's a weird property. A property of f of x and inverse, your inverse function, is if you take the composition function. So if you did not watch the videos, I'm sorry that you might be a little confused here about what composition function looks like, or what that even is. I'll give you a brief reminder. It's basically taking like the f of f minus, or inverse f of x, or the other way around, the inverse function of f of x. Basically, if you take the inverse function of your function of x, you should just come to x. What? Well, think about it this way. Go back to your diagram up here. I told you if you go x, right? You put it through a function, you put it through some equation, you get a result called the f of x, or you call it the y. Let's stick with this. Keep your eye on this guy here. If you take your output and put it back through the inverse function, you get back to x, right? So what this looks like is if I took the inverse function of f of x, I get back x. So it all connects. Does everybody see that? This looks like jargon, but this puts it all together, okay? So hopefully that kind of makes a little bit of sense. Okay, let's see here. All right, we'll stop there with the notes here, and then we're gonna just take a brief little break here. Still notes though, so just a quick reminder about logarithms. Reminder about logarithms. Let's see if anybody remembers how this works. Log 2, 8, I think, or is it log base 2, 8? What that basically means is you have 2 to the power of x is equal to 8. You're basically just trying to find out which exponent makes it so if you have a base 2, it comes out to 8, okay? Another feature, or another that I want you to quickly remember, is if you have a log base of x, it's natural log of x, okay? Does anybody kind of remember that? Does that kind of makes like familiar sense to you guys? Okay, so here's your sample problem. Here's your sample problem. You're gonna find the inverse function for f of x is equal to 3 minus the natural log of x plus 2. And prove your inverse function is the correct inverse function. Correct inverse function. Why don't you guys copy that down? I'm going to turn on the AC. I think it's a little hot in here. Does anybody remember how to solve for inverse functions? No? Teresa, your eyes kind of lit up a little bit? No? Okay. It's just like, what? What did you just ask me? Yeah, there's 2 ways you can do it. There's 2 ways you can do it. Okay. Do you guys want to... Actually, do you guys want to work on this on your own or no? Joseph? What? Okay, hold on. Let me start you off, okay? Because I forget this corner here is just like they're into it. They're on fire. They're into it. Okay, so they're I can't say that for everybody. Everyone's like I don't know. Okay, some people are excited, Mr. Wade. I'm not one of those people right now. Okay, all right, hold on. So just letting you know, you guys got this here. I'll just tell you what you got to do. You can either you can rewrite this. Okay, maybe this will make it a little bit easier. You have two options. Either you can change the positions of y and x. So you have x is equal to 3 minus ln of y plus 2. And then you just solve for what y is now. Or you can solve for x. Like you can work hard to solve for x here. Like you solve for x. And then you just switch the notation at the very end. Like, okay, this x is now... Does that kind of ring a bell or no? Do you guys want me to go through it? Or raise your hand if you want me to go through it. Raise your hand if you want to do this on your own. Give it a try.
I don't really care. I've already done it.
All right. Go ahead. All right, go ahead and work on this, okay? Go ahead and give it a try. If you don't know what to do, ask a partner, okay? Ask people around. Look at other people's work. This is not an exam, guys. I want you guys to be like, what is they doing over there, okay? Walk around, okay? I don't mind what you're going to do, okay?
At first, I wanted it to be easier.
Incorrect. No, I'm just kidding. You're correct. sorry, Matthew. Yeah. No, you're good. You're good, Matthew.
I wanted it to, first, up to here is not the inverse function because, when I put the y by itself, I wanted it to be easier. Then I switched the x and y here. So
Oh, okay. That's a very...
if I solve it from the top, if I change it here, then it's a little harder. You have to have more steps.
Yeah, exactly. Okay, all right. That's very smart. Wow, you're actually very smart in doing that.
Wait, what happened to your leg?
Oh, I was actually on no, it wasn't surfing. Surfing, you don't get that many injuries unless the board hits you. What's up?
Mr. Spiegelberg has a surfing.
Does he? Yeah, he has a... Yeah, you don't get too many scars, but you get a few scars if you surf long enough, I guess. No, this was from that longboarding, that weird longboard that I have. So that skateboard longboard, yeah, that one that has a weird truck on the front, yeah. No, not like skateboarding as in kick flips and tricks and stuff like that. Mine's just carving. We just carve and stuff, you know.
Did you wear hand gear?
No, I don't. I don't wear anything. So
You wear hand gear when you longboard.
really,
Yeah, because one time I was thinking about casual longboarding without gloves. I have them, but I was going down the hill. But,
oh yeah.
if you go down a decently steep hill, so there was a small hill. I went down and so I was like, hey, this isn't that bad. So I was gonna stop, but then I forgot that this hill was connected to the biggest hill in my neighborhood. It goes straight down.
Oh, okay. Dang, you got some rugby, didn't you?
Yeah, there's a road there. So.
Oh, let me take this off for captured on lecture.
Oh yeah.
That's crazy though. Yeah, that's right. You did have a massive injury. You had a huge scab on your elbow.
Yeah. No,
cool.
the finger, the hands. I didn't have my gloves, so I couldn't
slide, or I think that's how they plant. Yeah, that's too.
Yeah, I could usually go like this, so forward. Then, if I want to stop, I could just fall back. That's how you don't get an injury. But then I couldn't do anything, and I had to stop. So, and it was going fast, and there was a car coming. So, because it's a road, I didn't even I wasn't planning on going down that road. So, there wasn't that many options to stop. I couldn't put my
foot down, or a foot brake or something. That's scary, man.
So I had to
You're
jump.
probably going so fast.
So I had to jump off, which sucked.
That's scary. To make that commitment, I gotta do it. That's crazy.
Yeah. My friend, he couldn't do it, so he got hit by a car once.
Jeez. Okay.
I think he was trying to do something, but
Yeah. Man, that's pretty nuts, man. No, I would say my longboarding is definitely shorter than a traditional longboard, and you just carve on flat ground, or you find a nice hill, and then You don't ever go straight down with my board.
Mine is
Yeah.
like the long.
Yours
It
seems
has
like-
two tips. Like two,
Yeah.
it goes up. It's not like the surfboard. There's two small tips on the bottom.
Okay.
It's,
Yeah, that's cool. You gotta show me.
it's like it zooms way down. I gave it to my friend because I'm not gonna skateboard for a while.
That's cool, man. That's cool. Yeah.
It's
I only do it just to help with surfing. I don't do anything. I don't do it for anything else. Like people just like what was his name? Not Roland,
Pierce.
but Pierce was really into it. Just as
No, I've seen Pierce skateboard. We did it one time down the hill.
Yeah.
It was he's pretty good. Like he
Hey, seems like it.
he knows how to not accelerate as fast. He was using a small board, so it wasn't as fast as a long board.
Good. Yeah. I noticed he took my board pretty quick and learned it pretty fast. I was genuinely pretty impressed by him. So I was like, wow, you learned so much. I imagine you're pretty good too.
I'm decent. Pierce is more of a skateboard. Like he knows how to do a lot of tricks.
See, I don't like that. Yeah, that's where I hurt my ankles. And
Pierce is good at tricks. Like
really.
like he's more of a skate park type dude.
See, yeah, I call those skateboards. I don't know, just old school.
I'm more of like
that's skateboard. Longboard is just
I'm more of like a Casey Neistat, you know.
Casey Neistat?
Yeah,
you know?
I'm more of like his style of longboarding.
I haven't actually seen him longboard before.
Yeah, he has a lecture.
Oh, he does?
Yeah, that's what in all of his videos he's
One more minute, guys. We'll give you guys one more minute to solve for this.
super good. Like he's like using there's a controller so you can make it go and stop. He uses that. Then he has like a camera in his other hand.
Oh, the with the selfie stick?
Yeah, he has like this big camera with like this gorilla, like it's like a selfie stick sort of, and he like brings it around, and then I don't know how he does it. Then he's controlling a drone sometimes.
He's good. He's had so much experience recording himself though in many ways that his production value is good. His editing's really good too, and I guess like in multitasking, it's like on a different level than where we are right now. But not to say that you can't.
Yeah.
All right, guys. I'm gonna go ahead and stop you guys. So go ahead and return back to your desk. I'll work through it. What did everybody get? Did anybody get a final answer? Would anybody like to share their final answer? Hold on, Stephanie. You've been sharing all day, so I need someone else. Joseph, guys, did anybody of you guys solve for the inverse function at all? Risa, are you just being modest here? Okay, all right. You're just like, I did, but hold on, Mr. Wade. Before I share my card, you gotta, show me your cards, right? Okay, that's fine. Okay, so let's go ahead and work through this. Now, wow, Gray, you are actually going on and proving it, correct? Is that what you're doing right now, or no? I'm not sure. Okay, all right. No, great. It's fine. You can keep working too, as long as you know. Like I guess you can kind of, if you can follow along with my work already, you can keep working too. It's fine. Okay, so let's go through the first step, which is just to find the inverse function. And don't forget, we gotta prove if it is or isn't. So how are we gonna do that? And you guys are probably like, proofs, Mr. Wee. I don't want to prove. All right, on. Shh. Okay, so f of x, what is that equal to? Well, Mr. Wee, okay, you're going to see what he likes to do. I'm going to switch it to y is equal to 3 minus the natural log of x plus 2. What I'm going to do is I'm going to solve for x, and then I'm just going to switch the notation up, okay? So it's just, what do you call that? Or that weird idiom where it's like a, wherever, or like whatever. It's the same thing, I think, just slightly different. But it's pretty much the same procedure. So I'm going to solve for x. I'm going to subtract 3 from both sides. So that way I have this natural log here on this side here. Okay? And then I don't like the negative sign personally. I don't like dealing with it. So I'm going to divide both sides by -1 to make it a little bit easier on myself. So the natural log I'm dealing with is a positive natural log. It's easier to deal with, I think. And then this becomes basically -y plus 3 is equal to the natural log of, now a positive natural log of x plus 2. And then to get rid of the natural log, I'm going to put it as an exponent to the base of e. What that does is it sort of cancels out this natural log, giving me just x plus 2 is equal to e to the, well, I can rewrite this if you want to 3 minus y. I just kind of switched the order up. So the positive 3 is now in the front, and the negative y, or yeah, the negative y is now a minus y. So that completely works. And I subtract 2 from both sides, giving me e to the exponent of 3 minus y minus 2 is equal to x. And then at this final step is where I switch back the x and the y. So now it looks like this. E is going to be to the power of 3 minus x minus 2 is equal to y. And then basically, I just solve for the inverse function. So in place of my y, I'm going to say that that's my inverse function. Does anybody have any questions here before I move on, though? Because you're like, what just happened? Yes.
So the natural log of x plus 2, that negative is treated as the whole unit?
Yes. That negative is kind of like, yeah, treated as like it's distributed towards that whole thing. Yeah, so sorry about that. It might have made it a lot more, infinitely more complicated if you. So I give you a lot of credit though if you were dealing it like that, dealing with it like that. Okay, so check your inverse function. This is what you should have gone for your inverse function. There's a second step, however. I have to prove this now. Okay, proof that this is the inverse function. You might like this, you might not like it. What have I learned about dealing with my oops, this is not my notes, sorry. Sorry about that. Yes, they are my, yes, that's correct. If you look very closely, this is going to tell me how I'm going to prove this. If I take a composition function, meaning the f of my inverse function of x, if I take the f of my inverse function of x and I get x, that should prove to me that I have the right inverse function. Oh, wait, what are you talking about? Okay, let me show you. So if I take the inverse function of my f of x and I prove that that's x, or I think your book has you do it both ways, but just do it one way, okay? I'm going to save you some time, so I'm just going to say if you just do it one way, it's fine. Whatever you're more comfortable with. If you take the inverse function of f of x or the inverse function of f of x and prove that it's equal to x, then you're good. But what the heck does that look like? I still don't understand what's going on. Okay, so let's see. I think in my notes I ended up doing, what was it? The f of the inverse function of x is what I chose to do, okay? So let's back up a second. I think okay. Originally, sorry, I'll go back to that. The f of x right now, if you think about it, whatever's in the parentheses is where my input goes, okay? So in the parentheses is x. So x goes here, if you notice it. It goes in the natural log and it's added to 2. And the x is in here, okay? So I think you understand that, right? Don't be scared of what you see here. Think of what's in the parentheses, again, as what's going to go in where my input was. So my input was x, and it was put in this weird position, being added to 2, and you take the natural log of it. That's no different. This is going to look like this. 3 minus, I don't think you've ever seen it like this before, because I don't think anyone's ever written it out for you like this. It's like this. Plus 2. Okay, it's like this. In place where x used to be, now it's going to be the whole inverse function, right? And then we don't just stop there. We actually substitute in what the inverse function is that you got. The inverse function that you got was e to the power of 3 minus x minus 2. Simple enough, right? I don't think it's simple. I think it's pretty difficult, personally. Minus 2 plus 2. So again, I substituted for the inverse function of x. I put in what I got down here. Okay, sorry, I got down here. And then I noticed that the -2 and the +2, well, they'll cancel out. Oh, how convenient is that, guys? 3 minus the natural log of e to the power of 3 minus x. I know if I take the natural log of e, that will kind of cancel out and bring down what I have in the exponent to e minus, so it's kind of like, I don't like doing this, but I've never seen it done like that, but you can kind of think of it like that. This brings it down to 3 minus 3 minus x. Parentheses, please. So then if you think about it, 3 minus 3 is 0, and that negative sign gets what is it, distributed to that negative or that minus x, giving me a positive x. So in the very end, the composition function of f of inverse function of x is equal to x. So does that prove to me that I had the right inverse function? Yes, without a doubt, it does. Okay, I'm not going to do it the other way where you do the other one where it's the inverse prime, the inverse function of x, of f of x. It's sort of the same thing. But you should end up with, if you do the math correctly, x. Okay? All right, guys, I guess I will cut it short for today, but hold on. Just letting you guys know, on the video, on my next videos, I'm going to put up 3 different things. I'm going to put up another problem, or do you guys want me to go through another problem? Another one of these problems? Gabby, no? No, I'm good. Okay, so, I'm going to go over 1.6 in my other video, and I'm going to go through some just basic logarithm problems, okay, as review, all right? So 2 more videos after this. So I want you guys to watch this week this lecture, which you've already witnessed, so you don't have to rewatch this lecture. But I have 2 more videos I want you guys to watch for this week, okay? All right, guys, that's it. So thank you guys for coming to class. Please stack back your chairs in the back, and we're done with class. Thank you guys so much.